Hello everyone, my name is Uttam Kumar Bellamkonda and I'm here with my teammate Sucharita Reddy Damareddy Gari. We are here to present our final project, our topic is AI-driven stroke risk prediction in adults aged 45 through 60. To introduce our topic, we are basically doing on stroke. Stroke is one of the leading causes for death and disability worldwide. Predicting strokes early in at risk populations can drastically reduce complications. So we are basically aiming to do prevention is better than cure. The objectives that we had to go through were enabling early identification of individuals who are at elevated risk of experiencing a stroke, support healthcare professionals in making data-driven decisions for preventive care, and then utilizing existing clinical data effectively to create a non-invasive and scalable risk prediction tool. The literature review that we had went through were of mainly three articles, and the topics were of evaluating machine learning models versus traditional statistical approaches for stroke prediction, assessing deep learning techniques, and then developing a hybrid machine learning model for stroke risk prediction. The machine learning techniques used were logistic regressions and deep learning, deep neural networks, and then random forests. And then and the dataset description that we had went through was through source of Kegel stroke prediction data. We had used a dataset of 5,110 records of patient data, and the features included age, gender, hypertension, marital status, average glucose levels, and so on. The data pre-processing steps that we had went through were handling missing values, and we were able to handle the missing values by using median imputations and feature encoding transformed categorical columns like gender and smoking status. The pre-processing techniques that we had done was to retain top features based on predictive power and clinical relevance. The age, higher age linked to stroke risk, and average glucose levels, higher values suggested diabetes and stroke risk. We used a SMOT synthetic minority oversampling technique to balance the imbalanced data set. For data splitting, we use the 80-20 training and the testing percentage as it is standard. And the standardized features using standard scalar for model stability. Applied stratified five-fold cross-validation to ensure consistent performance. The mean ROC AUC across folds was 0.8670. The models that we had explored was a logistic regression, random forest, support vector machine, and gradient boosting models with recall F1 score and ROC AOC. And the model comparison results are as below.
From these results, we have chosen logistic regression as our model because it is having high recall value and ROC also very good 0.8146, and it is interoperable and easy to explain for clinicians. These are the reasons we chose logistic regression as our final model. And upon evaluating this model with the features we have and the data set we have, these are the result we have got, and which is good accuracy and precision and recall and all. And this is the confusion matrix for the final model where we have more true positive here. Coming to the probability calibration, we did this to improve prediction probability, and predictor probability was now 0.8146, which to enhance the real world decision making by providing more reliable risk sources. We tested this model giving a new patient data, like simulated patient data. We have given random values, so it predicted as stroke positive and 81% of probability, which is very good. And coming to the summary, logistic regression was chosen because it is interoperability and strong recall. Final model validate using cross validation, five-fold cross validation, and probability calibration improved the model reliability. And model performance is close to 0.849, which is by American Heart Association for logistic regression. And this is our one of the literature and we chosen. And features selected features or age, hypertension, heart disease, which is also aligned with the literature included in Hassan. We can develop this by including more clinical data sets to include generalizability and physical activity and medication history and cholesterol level. And also we can integrate time series patient data. We can explore ensemble methods and deploy the model in clinical decision support system for clinic real-time uses. We can use explainability tools like SHAP and LIME. And coming to the conclusion, this project successfully developed interoperable and reliable stroke prediction model tailored for adult aged 45 to 60. We use logistic regression and further validation on clinical data sets can be more useful for early interventions. And this approach can be scaled and integrated into AI-driven clinical decision support system. To quickly show our project here, after pre-processing and we chose logistic regression, we developed this model. These are the results and confusion matrix. We have simulated patient data here and it showed positive for stroke and probability of 0.81. Thank you.
Thank you.